There is so much to see and learn in space, but exploration faces a huge problem: distance. For example, the nearest star to us, Proxima Centauri, is 40,208 billion kilometers away from us. Even Mars, which Elon Musk wants to colonize, will require nothing less than 5 months of space travel. And that is if you take advantage of the best time to leave the Earth. However, long distances will no longer be an issue with the new innovation that Musk and NASA just revealed, the new speed light engine. What is the speed light engine, how fast is it, and what impact will it have on space travel? Join us as we explore the new speed light engine that defies physics, just revealed by Elon Musk and NASA. Not a few people believe that Elon Musk is biting off more than he can chew with his audacious plan to settle people permanently on planet Mars. It is easy to see why skeptics will take such a stance. Space exploration has been the purview of governments because of the complexities and huge expenses involved. However, for a visionary as focused as Musk, nothing is impossible. He is set about putting together everything that is needed for his enterprise, and the most crucial component is the transport vehicle. Musk has to work out how he will move not just cargo but humans from this planet to the Red Planet. That wouldn't have been a problem if not for the vast distance separating the Earth and Mars. The distance between the two planets is not constant, but the minimum distance is almost 34 million miles. For context, the new James Webb Space Telescope is in an orbit of the Sun that is 1 million miles away from the Earth, and the telescope endured a month-long journey before reaching its destination. Musk plans to use the Starship, a powerful spacecraft that his company SpaceX is developing and testing. Starship will be much faster than the JWST, but the Voyagers are still looking at a 5-month journey at the minimum. 5 months is a lot of time to spend in space as a human for several reasons. The colonizer's health is important, and radiation, which is abundant in deep space, can ruin your health. It can even render the travelers impotent, which is not ideal for the self-sustaining community Musk wants to establish on the planet. Apart from radiation, the colonizers have to bear the effect of staying so long under low-gravity conditions, which has significant effects on the muscles in the body. But most importantly, 5 months or above is a long time to spend in the middle of nowhere because anything could go wrong, even for the most meticulously made plans. In addition to all the hazards, Musk does not have much time. He has to transport tons upon tons of supplies and life-sustaining equipment before the first explorers even step on the soil of Mars. He even plans to transport more than 1 million people in a short while to form the nucleus of the new community. All these are reasons why Musk is still searching for a faster mode of transport, even though he is building the most powerful rocket ever. What options does Musk have as he searches for a very fast means of transportation to support his Mars ambitions? NASA might just have the solution. The space agency has collaborated with Musk many times. For example, Musk's company has been launching cargo and crew for NASA to the International Space Station. NASA is also invested in the Starship, as it will use it as a lander when its astronauts return to the Moon. For that purpose alone, NASA will pay SpaceX almost $3 billion. So it is not surprising that Musk and NASA may be collaborating on a solution that will make space travel tremendously fast using the speed light engine. However, apart from being fast, the new speed engine will not use a single drop of fuel. Sounds fantastic, right? Wait until you hear all of it. Propellantless proposals aren't new actually. In the late 1970s, Robert Cook, a US inventor, patented an engine that supposedly converted centrifugal force into linear motion. Then, in the early 2000s, British inventor Roger Scheuer proposed the EM drive, which he claimed could convert trapped microwaves into thrust. However, neither concept has been successfully demonstrated. Both are widely assumed to be impossible due to the violation of the conservation of momentum, a core physical law. But the new speedlight engine, known as the helical engine, is very fast. It can reach an astounding speed of 300 million meters per second. How fast is this? Going to the Moon, which is 240,000 miles, takes only 1.3 seconds. Musk's colonizers will be able to reach Mars in 12.5 minutes. If you set out for Neptune, which is 2.7 billion miles away, you will touch down in about 4 hours. Remember the Centauri Proxima mentioned at the beginning of this video? Instead of tens of thousands of years, the helical engine will take you there in just 4 years. That is still a lot of time traveling, but it is a lot more practical with the helical speed engine. Dr. Burns, who works at the NASA Marshall Space Flight Center in Alabama, unveiled the idea in a head-spinning paper posted to NASA's website. He wrote, This in-space engine could be used for long-term satellite station keeping without refueling. It could also propel spacecraft across interstellar distances, reaching close to the speed of light. Dr. Burns' mad idea is revolutionary because it does away with rocket fuel altogether, and this helps to solve a perennial problem with space travel. To get the idea, today's rockets like those built by NASA and SpaceX have to stock up on tons of propellants like liquid hydrogen to go to Mars and beyond. The problem is, the more fuel you load on your craft, the heavier it gets. Modern propellant tanks are far too bulky to take on interstellar flights, but the helical engine gets around this using high-tech particle accelerators, like those found in Europe's Large Hadron Collider. Tiny particles are fired at high speed using electromagnets, recycled back around the engine, and fired again. The simplest explanation is that the engine works by taking advantage of how mass changes at the speed of light. In his paper, Dr. Burns provides a concept to break this down that describes a ring inside a box attached to each end by a spring. When you spring the ring in one direction, the box recoils in the other, obeying Newton's laws of motion that state that every action must have an equal and opposite reaction. When the ring reaches the end of the box, it will bounce backward and the box's recoil direction will switch too. However, if the box and the ring are traveling at the speed of light, things work a little differently. According to Albert Einstein's theory of relativity, at such speeds as the ring approaches the end of the box, it will increase in mass. This means it will hit harder when it reaches the end of the box, resulting in a forward momentum. According to Dr. Burns, the design can produce a thrust up to 99% the speed of light without breaking Einstein's theory of relativity. However, the plan does breach Newton's law of motion by violating the laws of physics. But what does that matter as long as we get to our destination on time? Dr. Burns reckoned it would have to be 650 feet long and 40 feet wide to work, and it would need to generate 165 megawatts of energy to produce 1 Newton of thrust. That is the equivalent of a power station to create the force required to accelerate a kilogram of mass per second squared. If you think that is a lot of input for so small an output, think again, because the engine works in space where the vacuum renders friction non-existent. Mind you, before you hop on the helical engine, there are some things that you should know about speed of light travels. Of course, light would struggle to keep up with you, which will cause your vision to warp in bizarre ways. Everything behind you would appear black, and time would appear to stop altogether, with clocks slowing down to a crawl and planets seemingly ceasing to spin. Light to the sides of you would likely streak past in lots of bands of color, and light in front of you would arrive quicker than normal and thus appear bright and intense. Your field of view will narrow dramatically, but all of that doesn't matter if we can get to deep space. Let's hear what you think of the helical lightspeed engine in the comments section below.